You can actually pull electrical power from thin air if you're very clever about it, and that's because air is not thin, it's thick with lots of good stuff, like 78% of it is nitrogen, 21% of it is oxygen, and about 1% is carbon dioxide and other goodies like water vapor. And water vapor is the key to 2 out of the 3, well, really kind of all 3 methods that we're going to talk about right now. One is being explored at the University of Amherst in the distant past of 2023. And what they're doing is they're poking lots of tiny holes in a bunch of different kinds of substances. They think it doesn't really matter what the substance is. What matters is the size of the hole. If it's less than 100 nanometers, which is about 1,000th of the width of a human hair, it's likely to catch water molecules on the top. And because all water molecules have a little charge, they're going to leave some of that charge on the top, and the bottom of the hole won't have the charge, so that will create a natural battery. If you stack a whole bunch of this stuff on top of itself, you could create something in the range of a kilowatt battery, which if you ran it for an hour would be enough to power a light bulb for 10 hours or run a refrigerator for a day. 2 kilowatt hours, you could run an electric stove for 30 minutes. 4 or 5 kilowatt hours, you could run a dryer cycle, just to give you some perspective. So that's cool because the materials are common and you could build these things without taking up a ton of space. Method number 2 involves harnessing just the hydrogen using an enzyme produced by a bacterium, and it's luckily a very common bacterium. This is work being led by an Australian team, and what they've done is they've harnessed this bacteria, modeled it with simulations, and discovered what exactly it does to generate electricity from the air. And the way it does this basically is through very small channels. Again, it traps just the hydrogen molecules, excluding the oxygen molecules, thank you very much, and then using that hydrogen to make little tiny bits of electrical power. Now, you would need a lot of these bacterial enzymes to create such power, but because the bacteria is very common, you could produce it at commercial scale and generate enough enzyme to, say, power a wristwatch or a small phone or a toy. Thing number 3 that scientists are trying in your early 2020s is in the European Union. You're researching what you can do with thin layers of ceramic crystal stacked on top of each other. And what this does is, again, create very narrow channels through which the moisture in the air has to travel, and as a result of these small spaces, generate some electricity, again, by, using the differential of the charge to create a natural battery. So these things clock in an environment of, say, like 50% humidity, which is 50% of the potential absorption of water vapor into the air. It doesn't mean half the air is water. It means half of the air's available space for water has been taken up at 50% humidity. An 8 by 5 centimeter panel of this stuff can generate around 0.9 volts, which is about a AA battery. So that's, getting useful. And if you lined up a whole bunch of those panels, you could imagine it providing a similar service as a solar panel farm. But you could also imagine putting these panels on small objects and powering them directly. For reference, all of America in an average day exceeds 50% humidity. The least humid state in America is Arizona, which clocks in around 52 on a normal day. Up in Mississippi, down in Mississippi, over there in Mississippi, it gets very wet, around 82% humidity. None of these things, however, will work when it's very, very cold. If it's deeply freezing, all the moisture comes out of the air, so you would need an alternative source of power during that time. But during operational humid hours in most of the world, this is going to be a pretty reliable way to get cheap energy directly from the air. So 3 big takeaways from all of this research going forward. 1, by the end of the 21st century, all mobile devices will have some ambient air power mechanism. So if you've got a small electronic device, it's basically going to power itself. It's not going to need to be plugged in repeatedly and supercharged. It's going to have lots of different mechanisms of absorbing power from its atmosphere, environment, from the way you're handling it, from the radio waves passing through it, and from things like these moisture harnessing devices. Everything that's mobile and small basically self-powers by the end of the 21st century, and even some medium-sized things like vehicles use this ambient air power technology as well, at least to supplement their broader power needs. Thing number two, you've got a broad-scale alternative addition to your wind and solar and hydrogen green portfolio of sustainable energy. When you scale up this humidity harnessing tech, you'll be able to deploy it widely around the world in various situations. It will be variously useful, like if you've got a humidity-based heater, like a radiant heating system, you could use the humidity in the room to then power the system that pumps the water into the room in the first place, creating a bit of a virtuous circle of energy usage and expenditure. Finally, the biggest picture is the smallest one, which is to say that as the 21st century unfolds, many of your most exciting technological discoveries will involve harnessing the phenomenon of the very small, of the micro, of the nano. And basically, this is going to allow you to do a ton of different stuff that you couldn't do before. Nanotech, obviously going inside bodies and doing all sorts of brain and muscle and health things, construction tech with these little machines, purification tech to keep viruses at bay, cooking and food tech like cultivating protein. A lot of your science in the 21st century is opening the door to controlling this smaller realm of which you are well aware in the 2020s, but over which you have stumblingly, fumblingly, almost embarrassingly little control. So look out for big things in tiny spaces coming to a humid area near you. Okay, thanks, bye.